Welcome to Genesis of MS SQL. In previous video, we have discussed on how SQL Server execute query. Let me proceed one step forward by discussing on basic points which need to know for performance tuning. Let's start with our agenda for this video. We will discuss query lifecycle, stages of query lifecycle, CPU time and elapsed time, parallel processing, how and where we look CPU time and elapsed time, why we need to know about WaitType. Let's start with query lifecycle. Whenever we execute query against SQL Server, it can take three different stages at any time: the enable stage, running stage, and suspended stage. Let's see detailed stages in query lifecycle. Running stage, which means SQL Server actually using SQL resource like CPU time, memory, storage to execute query. Runnable stage, nothing but a query is ready to execute but waiting for its turn. Suspended stage, which means query is waiting for any other task to complete. Our query didn't get enough resource like CPU, memory, network to complete. It might be waiting for other tasks to release some resource. Let's proceed further and understand query execution time. Query execution time is nothing but a CPU time plus query wait time. CPU time is the amount of CPU cycle spent by a workload thread on a particular processor or CPU. Elapsed time is nothing but a total duration of that thread, the time it took from a start to end. Example, let's say there is a workload thread for a simple query. Let's assume box as a second. Green box has a query running in a second. Red box means query get suspended in second. Orange box means query ready to execute in 1 second. Let's say query runs for a bit, let's say for 3 seconds, and get hold for a 3 seconds as shown in figure. 3 green, 3 red, and after that it's going to ready to run or resume again for 1 second, that is the orange. After that it run for 2 seconds and completed, as last two both is green, 2 seconds. The total time we get, the time the thread actually spent on CPU is counted towards CPU time. That is that 3 green plus last 2 green, total 5 green. That are total CPU time. The time the thread actually spent on CPU is counted towards the CPU time. Total wait time is nothing but that red and orange, 4 seconds. Elapsed time, CPU time plus wait time, total 9 seconds. Let's proceed further. Parallel processing. Parallel processing is nothing but a multiple process work together simultaneously to run a single SQL statement. Let's understand with example. Let's assume 4 threads carrying workload of query, each run a processor for 1 second and complete all the work in one shot. Total, and assume 4 set of CPU of that rectangular box, ping box. Assume that rectangular ping box as a 4 set of CPU. It will run a SQL statement in one shot because there is a 4 CPU present for 4 threads. Then the total CPU we get 4 multiplied by 1 second, 4 seconds. Total wait time, there is no wait time, therefore it is a 0 second. Total elapsed time, it takes 1 second to overall complete. Let's understand a different other scenario. Let's assume a thread carrying workload of query, each run on a processor for 2 seconds and complete all the work in 2 slots. In first second, 4 threads, each one using each CPU and 4 thread waiting resource to free. In second, remaining 4 thread execute and complete the query execution. As shown in figure, you can see that total CPU time is 4 multiplied by 2 seconds. Total that is 8 seconds. Total wait time is 1 second. In that there is a red in starting 1 second there is a wait of 1 second for of that 4 trades, and for and total elapsed is 2 seconds. In overall 2 seconds the query executed success. Overall executed in 2 seconds. Therefore, that is the elapsed time, total elapsed time. Let's proceed further. If a query has higher elapsed time but low CPU time, that means there is some CPU contention or other resource contention. If a CPU is higher than elapsed time, then there is a good amount of parallelism in play. Let's proceed further and understand how and where we can look CPU and elapsed time. When we run a query with set statistics time on, we can see CPU time and elapsed time statistics for a query. Let's see the demo. We are running the query with set statistics statement on. It will provide CPU and elapsed time. Copy and new tab. We are running simple SQL select statement on table business entity address for schema person of database MS SQL DBA Genesis. And we are using set statistic time on, and after that and the end of this SQL statement we are using set statistic time of TSQL statement. When we run this, we will get the output, but along with that in message tab we will get CPU time and elapsed time. By using that CPU and elapsed time, we can check that CPU and elapsed time and tune accordingly and minimize by minimizing CPU or elapsed time. You can understand that by using that set statistic time on statement, we will get that CPU time and elapsed time. As we seen in a demo, that set statistic time on display the number of milliseconds required to parse, compile and execute each statement. It will provide a time in a millisecond of compilation, parse. Actually my query of demo is already compiled and parsed, therefore it doesn't give that information of parse compile. If we run first time query, it will provide that parse, compile and execute, parse and compile timing. In my query we already rerun that, we already previously run many times, therefore it's showing only execute time. Set statistic time off, it will not display the CPU and elapsed time statistics. Let's proceed further. Why we need to know about WaitType? We must understand why the query is waiting and why it's going to suspend it. there are a various wait type in SQL. We must understand this wait type so that we can do some tuning to avoid such waiting situation. For example, if a query getting a wait type resource semaphore, which means there is a lot of concurrent same query present on that instance, or there might be a possibility of there is not enough memory present on that instance. We need to check accordingly and tune that query, or we need to increase that RAM if there is not enough memory present on that. There is a one scenario. There is a lot many other scenario like blocking. There is a other scenario present. There are a various wait type present, and each wait type have different reason why it's coming and why that query going into suspended state. We will share more details on wait type in next video. Thank you. Please share and comment.